The source of diversity very often is, in fact, the natural environment. It can be the truly natural environment, a forest or Yellowstone, Old Faithful, which really was the source of the PCR enzyme. It was isolated by Tom Brock many, many years ago, deposited in the American Type Culture Collection, and simply was there as a strange bacterium that grew at very, very high temperatures. And Tom Brock had deposited the culture that he had isolated. And some years later, the idea of a high temperature tolerant enzyme being able to amplify DNA components was developed, and that, of course, became the basis of a Nobel Prize. So we've turned to the environment for those bacteria that carry enzymes that we can use to degrade pollutants. And we can actually look at the pattern of bacteria that are present in an environment and learn a little bit about what's there. For example, if it's very heavy metal rich, we will find that the bacteria that are present have the capacity to break down or transform the metals. If it's an oil-contaminated environment, studies that I did many years ago showed that the numbers of oil-degrading bacteria go way up because they're responding to that as a nutrient. So we can characterize the environment by the bacterial populations that are there. And then we can simultaneously utilize the populations that are there to enhance, enrich for those species that can carry out the degradation of oil, transformation of heavy metals from toxic forms to less toxic forms, or even to bind with organic matter so that they become less potentially harmful. So we can use what's there in many ways, and it's important for us to understand what's there because then they can provide tools for new industry, new companies, new products in the future.